Hello guys, how is it going? Today we'll be continuing with our video regarding prime number, printing out prime number. Yesterday we used one of the approaches that was really frequently used, but this time we'll try to print out prime numbers a little bit in a more efficient way that will consume less resource. So let's see, let's just open our atom. Okay, so this was the prime number that we did last time. As you can see the output, we printed out all of the prime numbers from 1 to 100, and to print out this much, how many prime numbers are there? Let's see, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. So to print out 25 prime numbers, we had to loop 4950 times, which is too much. Let's see if we can decrease the loop to make our code more efficient. I would like to leave it as it is. I just want to create another file and call it prime2.php. okay, so let me just copy the same. Okay, let me just copy the same. And what I want to modify over here is, before rushing the code, let us first try to analyze our algorithm, what we are about to change. Okay, so the lowest number that divides, or the highest number that divides 6 is 3, and that is for sure. We know that any number bigger than 3 cannot divide 6, because 3 is exactly half of 6. So at the number, for example, 3 times 2 is 6. So any number times 2, or let's say if we have a number and 6, and we are checking against 6, then we can check it starting from 3, because we are for sure 4 will not divide 6, or 5 will not divide 6. So we don't have to check for 5 and 4, and that is for sure. Similarly, let's say we have another number that we want to check, which is let's say 20. So the biggest number that will divide 20 is 10, and that is for sure. 11 is never going to divide 20, and 12 is never going to divide. By saying divide, what I mean to say is exactly divisible. So the biggest number that exactly divides 20 is 10. So in the previous programming, what we did was we checked and we looped through each and every number that is lesser than 6 or lesser than 20 or lesser than 7. So in order to check if 6 is a prime number, what we had done was we had tried to divide 6 with 5, 4, 3, 2, and all those numbers that is lesser than the given number. So but what we can do now is, instead of checking through each and every number, let us start from half the way, which is 3. So if we check 6 by 3, then in that case we don't have to we can just skip out any number that is bigger than 3. That is in the case when 6 is even. What if 6 is, let's say a number is odd, for example 21. In this case, what we can do is we can just let's say if the number is odd, what we can do is we can start from 11 instead of 20. Instead of 10 for 20, what we can do is we can start our loop from 11 instead of 10. So let's see. So what I'm trying to do here is I will first of all check if I is even or odd. So if $I modulus 2 is not equals to 0, okay, is not equals to 0, then in that case what I want to do is, instead of starting from I would like to start from $I plus 1 divided by 2, which means I just walk through the code and I'll set this value to be j. And if I is even, in that case I would just say j equals to $I divided by 2. So Okay, here we need to have 2. So we have calculated the value of j, and this j, as we know from yesterday's video, that the value j means the second loop, the starting point of the second loop, which we are keep on decreasing in every loop. So we have actually found out where do we need to start our loop from. We don't need to go exactly right away from the number that is less than 6. In case of 6, we don't have to loop through 5, 4. We can just start from 3. That's what we are trying to do. We are trying to find out our starting number. So if the number is 6, let us say, then 6 modulus 2 is not equals to 0. That is not true. So it will go to else. So j will be I divided by 2, which means 6 divided by 2, which is 3. And in case of 21, we know that j is odd. So in this case, j equals to I plus 1, which means 21 plus 1, 22 divided by 2, which is 11. So our loop starts, our second loop begins from 11 and moves on till 0 or 1. Oh, I mean here 2. So that's what we have done. Now let us try to see if we still get the list of prime numbers, and we'll also check what would be our counter. So I'll just copy the same URL, paste it over here, and instead of prime, I just want to do it prime 2. And we can see we still got the list of prime numbers, but the loop is still 4950. And how is that possible? Oh, we forgot to change this I. We don't need let's say what I'd like to do is, instead of calling it j, let me just call it start, because this is the place where we start our loop from, and I would like to say j equals to start. Okay, j equals to start. Let's see now. See, we printed out the exact same result, but this time the loop is almost half. And actually, yes, it's almost half. So this way we have improved our code by, let's say, 100 times. I mean 100%. So here we have 2450 loops, and here we have exactly 100% more loops. So our code now with prime 2, with this new approach, we have reduced the loop count from 4950 to 2450, which is actually lesser than half. Previously we had to loop 4950 times, and if we divide 4950 by 2, then we get 2475, but here we have 2450, so it is better. This one is more efficient, and here the count of our loop is even less than half, okay, of the previous method. So this way we can make our prime number printing process more efficient and faster. Now if we loop 5,000 times, 10,000 times, I mean if we have to find our prime numbers from 1 to 5,000 or 10,000, our number of loops will be drastically reduced, and we can get more result without disturbing our resource. So this was another method of prime number. I would like to discuss one more method of prime, but I think the video would be too long, so let us just end our video here, and I'll see you in another video.